Good day, everyone. This video is recorded on the last days of 2022, the last days of December 2022. And this video is a follow-up video for a video that I did 2 years ago about Databricks networking. That got me the highest views, the highest likes in the channel. Because people really needed this video, and I made the video to teach, not to demo. It's not about demonstrating something cool, but it's about teaching how we can understand this. So 2 years ago that happened, and many things happened over the 2 years. We have now the SCC, the secure cluster connectivity. We have private backend endpoint, private front-end endpoint. We have all the sorts of things that quite confusing sometimes. I wanted to create probably not one video. I will make it divided into 2 or 3 smaller videos to discuss all about Databricks networking in a deep dive. Stay with me. All right, as usual, we are starting with the whiteboard, and we need to distinguish between 3 areas, 3 network areas. The control plane here, the control plane is the area where you have the web interface for Databricks. You have also the APIs for the Databricks workspace. So whenever you are connecting to the workspace web interface, that's actually not hosted inside the data plane, which we'll come to in a minute. But now it's all hosted in the control plane. The control plane is hosted by Microsoft Azure. I'm speaking about Microsoft Azure specifically when it comes to Databricks. However, will be a similar setup when you are discussing this in different cloud providers. So here, this is in a subscription controlled and maintained by Databricks, and this is not something that you can control as a customer of Databricks. On the other hand, in the bottom here, this is the data plane. That's where the clusters, the Spark clusters, resides. Every time you are starting a cluster, there will be virtual machines. You can see them. You can see like a GUID named with GUID, random GUIDs, virtual machines. They are in a cluster setup and they are connected together, and they are communicating with the control plane. Now, how it's communicated with the control plane? Before, we used to have a public IP per machine, and if you are a cloud admin and you say, well, I have a policy that prevents this from happening, that cannot happen, it's actually avoiding the policy. There is a way, it's not a magic or anything. There's no exception specific to Databricks. They are using something documented to avoid violating any policy. So the policy, even if you have a policy that says there is no public IPs, still Databricks clusters in the old model is using public IPs. Now, this is old. This is used to be the only way before for communicating. However, now we have something new. It's called the SCC, or the Secure Cluster Connectivity. In the SCC, there is no public IPs. Public IPs gone. How the communication happens? It happens through the Azure Relay. It's a service to communicate between on-prem and a cloud resource. You can use Azure Relay on your own for your custom applications. Azure Relay actually depends on Azure Service Bus, and it's used in many implementations in Data Factory, self-hosted runtime, in Power BI, data gateways. All these are using the same technique. The technique is simple. It's like, there is a queue here, and every time the control plane wants something from the data plane, it puts a message in the queue, and then the data plane is constantly pinging this queue, asking for message. It's very similar to the the model, if you'd like to have a metaphor for something day to day, is the community mailboxes. When there's a mailbox for every house, but it's not attached to the house itself. It's in one area, and you have to go every day to check your mailbox from this community area. And whenever someone wants to send you something, it will send it there, and you are retrieving the message or retrieving the command in this case for the cluster and executing the cluster. Okay. Does this mean that the only communication is going to the queue only? No. There are other things in the control plane that we need to communicate to, the SQL for the external metastore and similar. We'll go through them in a moment. But the idea is we have now a new mechanism for communicating between the data plane and the control plane, which is the secure cluster connectivity. And we'll see some demos for some variations. How can we enable it, and what does it mean exactly? I want to highlight something here as well, which is the area where the user resides here. So the user resides in a network that is, I assume it's not the data plane and it's not the control plane, of course. You can have, I see customers, they want to have one big VNet for anything analytics. Yeah, it works. What the user workstations or the user connections will be coming from a subnet different than the subnet for the Databricks. However, always have dedicated 2 subnets for Databricks, and that we will come to them in the demo to explain them. Speaking of the subnets, now before we used to have 2 subnets, where one we call it, so here it will be divided into 2 subnets. One we call it the public subnet, and then another called private subnet. Do we still have the same thing? Yes, as naming. However, effectively, both are actually private because there is no public IPs created anymore. That's why in my demos, I stopped using public and private, not to confuse people. I'm now using subnet 1, subnet 2. Is it still necessary, like network-wise, to have 2 networks? Well, Databricks still dictates this. This is how Databricks is designed. Can they later remove this and make it only 1 subnet? There is nothing to, network-wise, there is nothing that requires to have 2 subnets. However, it's up to Databricks to implement this or not. Until now, we will always have 2 subnets. The same rules that you used to have before about the subnets, what's the size, the minimum size for each subnet, this is still the same. The 2 subnets are identical because every single machine will have 2 network cards. One network card in the subnet 1, another network card in subnet 2. Again, I'm not going to call them public or private. I'm going to call them now subnet 1 and subnet 2. So identical in size because every machine will have 2 network adapters, one in each subnet, so the size will be the same. Now, how big is the size? It depends how big is the clusters. Are we expecting to have 10 nodes clusters, 16 nodes cluster, 100 nodes cluster? It's really up to you. Can we have multiple Databricks workspaces sharing the same 2 subnets? No. This is still a limitation. For each workspace, you need to have 2 subnets. So we need to design the subnets based on one workspace expected number of nodes for the clusters. Does all the clusters lives in the data plane? Yes, except there's one exception. The serverless SQL, that this is the SQL warehouse in Databricks. The serverless clusters are actually created inside the control plane here. So that's still the exception when it comes to the clusters. However, that's why we call it serverless, because they start very quickly, because they are always running. You're just having one shared environment, and that's the concept behind serverless. Okay, with this, let's move to a demo. Before we start the deployment, let's check the VNet that we are deploying to. So it's one simple VNet. It has 3 subnets so far, Databricks 1, Databricks 2. These are the 2 subnets that we'll use. As you can see, there is no delegation, there is no security groups. It's a completely new VNet with no configurations whatsoever so far. Now let's create it. Choose a Databricks name. Now, networking. This is the important part. The first one, it dictates whether or not you will use the secure cluster connectivity. So yes, that means we don't need to have any public IPs. The second one is asking us whether to deploy in our own VNet or not. Then I will say yes, and I'm choosing the configuration that I have already. So these are pre-existing subnets. I'm just copying whatever configuration I have already. Now this is important. Here it asks me, shall Databricks add the required NSG rules or not? Two options here. All rules, that means there is no need, as the message says, there is no need for private endpoint, or to be exact, the backend private endpoint. If we are choosing no Azure Databricks rules, then now there is a need for the backend private endpoint, and we will discuss the backend private endpoint in a later point. But for now, I want to test it without the backend private endpoint, without including any NSGs, and we'll see how it works. So executing, now it's done. Let's go back and refresh our network. I see there is security group. So although we said no NSG, there is still NSGs attached, and there is still some rules included. When you look at the rules here, you will see in the outbound rules, we have rules to connect to SQL, storage, and Event Hub already added. There is one rule missing, which is the connectivity to Databricks. This is the option that you are toggling in the setup, whether to add the rule for the Databricks control plane or not. When you say no, in our case, for example, then you have either to add it manually later, the NSG rule, or you need to add a backend private endpoint. Checking the other subnet, it's exactly the same. So the two subnets are identical from the NSG perspective. All right, the workspace successfully created. However, the expectation is we will not be able to create a cluster because we are missing one network path from the data plane to the control plane. So what I'm doing right now is I'm creating a new personal cluster, setting the termination to 30 minutes, executing. It will take some time, and then eventually it will fail. Now it failed, and I can see that the control plane request failed because there is no communication between the data plane and control plane. So as we saw, without all the required NSGs, the Databricks, although the workspace is created, but Databricks failed to create or start a cluster. Now, we have two options, either to create NSG role, like add a new role, to allow the communication between the data plane and the control plane, or create a private endpoint. Before we go for the private endpoint, I want to test first the NSG. So what I will do in the next demo is I'm going to recreate again the same workspace from scratch. However, in this option, I'm going to choose all the NSG roles, and then I will compare between the previous one and the new one and what exactly the NSG role that is unique when we are adding the new one. So I'm starting from brand new VNet without any NSGs, and I'm going to create a new Databricks workspace. In this workspace, I'll choose to have no public IPs. I'm going to choose my own VNet, filling the information of the subnets. And then I'm going to choose to have all the rules, all the NSG rules required for Databricks. This is the difference between the previous one and the new one. Executing, and what I will do after is I will go to the network, the subnets. Now I see the NSGs added, and I see the rules, and there is a new rule now. It is for port 443 from the virtual network
to the Databricks. I'm comparing right now the previous screenshot with the new rules, and I can see the only one is going to Databricks and I'm allowing this traffic. This is a service tag. So these are IPs, but the cloud provider, Azure in our case, is maintaining this with the service tag. So I don't have to mention all the IPs. Now I'm going to repeat the same thing again, create a cluster, and in this case, the cluster will be successful. So to summarize, so far we discussed the new Databricks networking model with the secure cluster connectivity, meaning without any public IPs. And now we know that to have the communication channel between the data plane and the control plane, we need to have NSG rules that allows the traffic from the VNet into the Databricks service tag to be allowed on the port 443. We saw a demo of a failure cluster creation and successful based on the availability of the NSG or not. Now, the next video, we will discuss the private endpoint and we'll see how can we secure this not with NSGs but with private endpoint.